Well, welcome to this online revision session for AQA FP2. We're going to cover the January 2011 question 2 on the topic of method of differences. As you can see, this question has two parts. In the first part, we're asked to find the difference between UR and UR minus 1 and show that it equals R times 2R plus 3. And then in the second part, using that result and the method of differences, we can find the sum of the first 100 terms of this particular series that we've been given. So, on to the first part then. Bit of algebra here. So we want UR minus UR minus 1. We know that UR is defined as a sixth of R plus 1, 4R plus 11, and then we've got to subtract a sixth, and we're replacing R with R minus 1, so we get R minus 1, then R minus 1 plus 1, which is going to give us R, and then we've got 4 lots of R minus 1, so that's 4R minus 4, but we got plus an 11 on the end there, so the minus 4 and the plus 11 gives us plus 7. Now we've got to simplify this expression, so vast majority of the time looking for common factors will be the easiest approach to this. So we can see we've got a 6 R in both parts, so now we've got to multiply out the R minus 1 and the 4R plus 11, so that will give us 4R squared. Then we get plus 1 times the 4R and the R times the 11, which will give us a total of 15R. And then we got plus 1 times the 11, so that's plus 11. And now we've got to do the same in the second part. We've got R minus 1 times the 4R plus 7. And I would suggest you put this in a bracket because you're subtracting all of this. So we get R times the 4R, which is again 4R squared. Then we get a minus 1 times the 4R and the 7 times the R, so that will give us plus 3R, and the minus 1 times the 7 gives us a minus 7. Now we have to simplify this, so we've got 6R, and then we can see, well, the 4R squareds will cancel. So we've got 15R minus the 3R, which gives us 12R. And then we've got an 11, take away a negative 7, which gives us 18. So we can see that has a common factor of 6, which with the 1/6 will cancel to give us R times 2R plus 3, which is the required result. There you would get 1 mark for indicating the correct method at the beginning here, and then a mark for having an answer, an unsimplified answer like the one we've got here for UR minus 1, and then a correct answer mark at the end, which will give us our 3rd mark. Then on to part B. As I said, we're going to use the results from part A, which I've written up the top here. So we can see, what are we doing? We're trying to sum the first 100 terms. So the first value of this is when R is 1, going through to when R is 100. So we could write this in sigma notation as the sum from R equals 1 to 100 of R times 2R plus 3. But we know that the 2R plus 3 can be rewritten, so we get the sum from R equals 1 to 100 of UR minus UR minus 1. Now if we wrote that out longhand, we would know that when R is 1, this is U1 minus U0. And then when R is 2, this is U2 minus U1. And then when R is 3, it's U3 minus U2. And so on, all the way to the last term, which is going to be U100 minus U99. Now we can see that if that's the case, that the only terms that are going to be left when we cancel out the terms, like this U1 goes out with this one, and this U2 goes out with this one, and this U3 will go out with the next one, and so on and so on. So the only things that will be left will be the minus U0 and the U100 out of the last bracket. So this just becomes U100 minus U0. And so now we can use the result of the 6R, R plus 1, 4R plus 11 and substitute in. So we get a 6 of 100 times 101 times 4 times 100 plus 11 gives us 411. And we've got to subtract U0, which is going to be a 6 of 0. So that doesn't really matter. That term will disappear. And so if we complete that calculation, that will give us the result that we require of 691,850. Okay, so where do we get the marks for that? Well, attempting to use the method of differences, that will give you a method mark of 1. For coming up with the result that it's a U100 minus U0, will give you an answer mark of 1 there. And finally, getting the correct answer at the end, the 691,850, will give you your third mark. Well, if you want to see more questions and get further support for your work, please go to the Further Maths website for assistance.